Okay, so this is the video for my bonus section of the lab, the Bluetooth connection, so sending and receiving from the client and the server. So I'll just quickly show in terms of the code. You can see here, this is the a Linux computer that I'm using as the client. And then here's my laptop with the VNC open of the Raspberry Pi, which will be the server. So in terms of the server side code, I didn't really change a whole lot apart from the GitHub, apart from adding in the functions from the previous lab that can move the car and use the sensor, since we're going to be sending data back and moving the car based on the commands of the client. So that's really all that was changed there. As far as the client side code, again, nothing really changed apart from adding in this function here. In both cases, I changed it so that the terminal wouldn't just be printing RPI in a number or PC in a number. It'll take in the commands. So I'll just quickly show that these two are connected. Since this is my client side is a Linux computer, I can use the Bluetooth CTL and just show that I'm connected to the Raspberry Pi. And then I will quickly show that as well on the server side. I'll just do devices. So you see I'm there connected, that first device. So now I will just quickly run this client side code. So now that's running, I will run the client side Python file. So you see here, it's going to ask for me for a command. It's going to first say I'm connected to the server. So just to show that, I just set it up for forward and backward. So if I tell it to move forward before I hit enter, I'll show this. So when I hit enter, it will move forward, and then it will send data from the client back to the server, or from the server back to the client, just telling me that an object is 34 centimeters away after the movement. So then I can type in backward, hit enter, and you see it move back, and it tells me it's 52 centimeters away. So I can just go forward again, hit enter, we'll move, and then we're back to about 34 centimeters away. Okay, so this is just a quick tutorial of my Raspberry Pi interacting through Wi-Fi and the Electron application. So what you see here is my Pi through the VNC on my laptop. So there's the Pi there. I've already executed this application, so I've started Wi-Fi _server.py. And now what you see here is the server desktop. So I'm going to go ahead and run npm start from the Electron folder that I have. This is going to open up the application. So this is the exact same front end, except with a couple slight changes. So I changed the image as well as the statistics that it pulls from the Pi itself. So I used ultrasonic distance, CPU temperature, and CPU frequency, and I've set this up to send a new value back to the client from the server every time a movement is made with the car. So I'll just quickly show the movement mapped to the keys. So the W key would move it forward, and the S key would move it backwards. A and D also turn the car, but since it's on carpet here, it won't turn as well, but I can still sort of show that. But that's that, and you can see now, upon doing that, it's giving a new movement or a new statistical value for each of those fields after every single movement that's made. So I'll just go backwards now, and it'll get a new values you see for the ultrasonic sensor, CPU temperature, and CPU frequency. So that executes every single time. And then you can see this reflected on the server side. It's sending what specific key value, so that 68, 83, 83 is basically saying what it's receiving from the client. All right, now I'll get into depth on the code that was used for this. So the only two files that I really had to make changes to in order to complete the lab compared to what was given through the GitHub and through the tutorial was this Wi-Fi server code here, and then on the client side computer, I had to make changes to the JavaScript and the HTML files. But I'll start with the Wi-Fi server code. So you can see that I have this class ultrasonic, which is essentially the stuff from the previous labs that was just used to use the ultrasonic sensor and get data back from that, the distance that stuff was in front of the car, and then the movement functions. So that would be used on the server side in order to execute the movements sent from the client. So you see I have two other functions here, get CPU temp Fahrenheit and get CPU frequency. So that's just going into the system files of the Pi and pulling out a value, and then using that later on we return that to the client side. And so given that, you can sort of see the logic here. I believe this was all in the code initially. I changed some of this such that, as you can see, when certain numbers are sent in the received message there, those correspond to the different keys on the keyboard, moving the car left, forward, right, and backward. So upon receiving those, we call the ultrasonic class and then the specific movement that's required there. And then beyond that, we get the CPU temperature, the CPU frequency, and then the ultrasonic distance using those functions I showed before. I then return those values as a response to the client. So this is what it would receive if we were to console.log it, for example, in the JavaScript code. It receives this sort of string of data here with the values put in. So that occurs every single time a movement is sent from the client side. So given that, I'll get into in the next step how my client sort of decodes that and then displays that information on the client Electron app. Okay, getting into the client side code here now. So this is all within the code that's ran when I run that npm start command in the command line from the Electron folder. So this is all related to the Electron application. So the only two files I actually had to edit were the index.js and the index.html files. So you can sort of see what's going on here. The client receives data from the server, and we log that as a message. And then I use regex in order to get the temperature value, the frequency value, and then the ultrasonic distance value. So you can see that this is pulling from that single string, just pulling out the value. Or rather, it's not pulling it there, but it's isolating it here. And then in the next value, you see that we pull the second value of that array. And we associate that to the CPU temperature, the CPU frequency, and then the ultrasonic distance. So that's what that does. We have a document.getById and then a element there, and then we assign that to the whatever variable we're doing there. So in this case, I just kept the basic names that were given in the code. So really, speed is the temperature, temperature is the frequency, and then direction is the ultrasonic distance. Beyond that, this is the code that is used to send. This was in the default code already, but this is what sends the data for what keystroke is pressed and can move the car. Beyond that, some slight changes need to be made to the index.html file. So I just changed the text that displays, and you can see that here we're displaying the ultrasonic distance, the CPU temperature, the CPU frequency, and then associating it with that ID value that was grabbed in the other screen.